can we take it all the way to Cursor? And what is Cursor? It's a fork of VSCode, and VSCode is one of the most popular editors for a long time. Like, everybody fell in love with it. Everybody left Vim. I left Emacs for it. Sorry. So it unified in some fundamental way the developer community. And then you look at the space of things, you look at the scaling laws, AI is becoming amazing, and you decided, okay, it's not enough to just write an extension for VS Code because there's a lot of limitations to that. We need, if AI is going to keep getting better, 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 we need to really like rethink how the AI is going to be part of the editing process. And so you decided to fork VS Code and start to build a lot of the amazing features we'll be able to talk about. But what was that decision like? Because there's a lot of extensions, including Copilot, of VS Code that are doing sort of AI type stuff. What was the decision like to just fork VS Code?
So the decision to do an editor seemed kind of self-evident to us for at least what we wanted to do and achieve. Because when we started working on the editor, the idea was these models are going to get much better, their capabilities are going to improve, and it's going to entirely change how you build software. Both in you will have big productivity gains, but also radical in how like the act of building software is going to change a lot. And so you're very limited in the control you have over a code editor if you're a plugin to an existing coding environment. And we didn't want to get locked in by those limitations. We wanted to be able to just build the most useful stuff. Okay,
well then the natural question is, VS Code is kind of, with Copilot, a competitor. So how do you win? Is it basically just the speed and the quality of the features?
Yeah, I mean, I think this is a space that is quite interesting, perhaps quite unique, where if you look at previous tech waves, maybe there's kind of one major thing that happened and it unlocked a new wave of companies. But every single year, every single model capability or jump you get in model capabilities, you now unlock this new wave of features, things that are possible, especially in programming. And so I think in AI programming, being even just a few months ahead, let alone a year ahead, makes your product much, much, much more useful. I think the Cursor a year from now will need to make the Cursor of today look obsolete. And I think, Microsoft has done a number of like fantastic things, but I don't think they're in a great place to really keep innovating and pushing on this in the way that a startup can.
Just rapidly implementing features.
And push, and kind of doing the research experimentation necessary to really push the ceiling.
I don't know if I think of it in terms of features as I think of it in terms of like capabilities for programmers. It's that as the new one model came out, and I'm sure there are going to be more models of different types, like longer context and maybe faster. Like there's all these crazy ideas that you can try, and hopefully 10% of the crazy ideas will make it into something kind of cool and useful. And we want people to have that sooner. To rephrase, it's like an underrated fact is we're making it for ourselves. When we started Cursor, you really felt this frustration that, you could see models getting better, but the Copilot experience had not changed. It's like, man, these guys, like the ceiling is getting higher. Like, why are they not making new things? Like they should be making new things. They should be like, where's all the alpha features? There were no alpha features. It was like, I'm sure it was selling well. I'm sure it was a great business, but it didn't feel. I'm one of these people that really want to try and use new things, and it was just there's no new thing for like a very long while.
Yeah, it's interesting. I don't know how you put that into words, but when you compare Cursor with Copilot pretty quickly started to feel stale for some reason.
Yeah, I think one thing that I think helps us is that we're sort of doing it all in one, where we're developing the UX and the way you interact with the model at the same time as we're developing like how we actually make the model give better answers. So like how you build up the prompt or like how do you find the context, and for a Cursor tab, like how do you train the model? So I think that helps us to have all of it like sort of like the same people working on the entire experience end to end.
Yeah, it's like the person making the UI and the person training the model like sit to like 18 feet away. So
often they're the same person even.
Yeah, often even the same person. So you can create things that are sort of not possible if you're not talking, you're not experimenting.
And you're using, like you said, cursor to write cursor.
Of course.
Oh, yeah.
Yeah.
Well, let's talk about some of these features. Let's talk about the all-knowing, the all-powerful, praise be to the tab. So the, autocomplete on steroids, basically. So how does tab work? What is tab?
To highlight and summarize at a high level, I'd say that there are two things that Cursor is pretty good at right now. There are other things that it does, but two things that it helps programmers with. One is this idea of looking over your shoulder and being like a really fast colleague who can kind of jump ahead of you and type and figure out what you're going to do next. And that was the original idea behind, that was kind of the kernel of the idea behind good autocomplete, was predicting what you're going to do next. But you can make that concept even more ambitious by not just predicting the characters after your cursor, but actually predicting the next entire change you're going to make, the next diff, the next place you're going to jump to. And the second thing Cursor is pretty good at right now too, is helping you sometimes jump ahead of the AI and tell it what to do and go from instructions to code. And on both of those, we've done a lot of work on making the editing experience for those things ergonomic, and also making those things smart and fast.
One of the things we really wanted was we wanted the model to be able to edit code for us. That was kind of a wish, and we had multiple attempts at it before we had a sort of a good model that could edit code for you. Then after we had a good model, I think there have been a lot of effort to make the inference fast for having a good experience, and we've been starting to incorporate. I mean, Michael sort of mentioned this like ability to jump to different places, and that jump to different places I think came from a feeling of, once you accept an edit, it's like, man, it should be just really obvious where to go next. It's like I'd made this change. The model should just know that like the next place to go to is like 18 lines down. Like if you're a Vim user, you could press 18JJ or whatever. But like why am I doing this? Like the model should just know it. And then so the idea was, you just press tab, it would go 18 lines down, and then it would show you the next edit, and you would press tab. So it was just you, as long as you could keep pressing tab. And so the internal competition was, how many tabs can we make someone press? Once you have like the idea, more sort of abstractly, the thing to think about is sort of like, how are the edits sort of zero entropy? So once you've sort of expressed your intent and the edit there's no like new bits of information to finish your thought, but you still have to type some characters to like make the computer understand what you're actually thinking, then maybe the model should just sort of read your mind, and all the zero entropy bits should just be like tabbed away.
Yeah.
That was sort of the abstract version.
There's this interesting thing where if you look at language model loss on different domains, I believe the bits per byte, which is kind of character normalized loss for code, is lower than language, which means in general, there are a lot of tokens in code that are super predictable, a lot of characters that are super predictable. And this is, I think, even magnified when you're not just trying to autocomplete code, but predicting what the user is going to do next in their editing of existing code. And so, the goal with Cursor Tab is let's eliminate all the low entropy actions you take inside of the editor. When the intent is effectively determined, let's just jump you forward in time, skip you forward.
Well, what's the intuition and what's the technical details of how to do next cursor prediction? That jump, that's not so intuitive, I think, to people.
Yeah. I think I can speak to a few of the details on how to make these things work. They're incredibly low latency, so you need to train small models on this task. In particular, they're incredibly pre-fill token hungry. What that means is they have these really, really long prompts where they see a lot of your code, and they're not actually generating that many tokens. And so the perfect fit for that is using a sparse model, meaning an MOE model. So that was kind of one breakthrough we made that substantially improved its performance at longer context. The other being a variant of speculative decoding that we kind of built out called speculative edits. These are two, I think, important pieces of what make it quite high quality and very fast.
Okay, so MOE, mixture of experts, the input is huge, the output is small.
Yeah.
Okay, so like what what else can you say about how to make it? Is caching play a role in this particular?
Caching plays a huge role. Because you're dealing with this many input tokens. If every single keystroke that you're typing in a given line, you had to rerun the model on all of those tokens passed in, you're just going to, one, significantly degrade latency. Two, you're going to kill your GPUs with load. So you need to design the actual prompts used for the model such that they're caching aware. And then you need to reuse the KV cache across requests, just so that you're spending less work, less compute.
Again, what are the things that Tab is supposed to be able to do kind of in the near term? Just to like sort of linger on that. Generate code, like fill empty space, also edit code across multiple lines.
Yeah.
And then jump to different locations inside the same file.
Yeah.
And then like
hopefully jump to different files also. So if you make an edit in one file and maybe you have to go to another file to finish your thought, it should go to the second file also.
Yeah.
And
then
then
the full generalization is like next action prediction. Like sometimes you need to run a command in the terminal and it should be able to suggest the command based on the code that you wrote too. Or sometimes you actually need to, like, it suggests something, but you it's hard for you to know if it's correct because you actually need some more information to learn. Like you need to know the type to be able to verify that it's correct. And so maybe it should actually take you to a place that's like the definition of something and then take you back so that you have all the requisite knowledge to be able to accept the next completion.
So providing the human the knowledge.
Yes.
Right.
Yeah.
Can you integrate, like, I just gotten to know a guy named PrimeGen who I believe has an you can order coffee via SSH.
Oh, yeah.
Oh, we did that.
We did that.
So can that also the model do that? Like feed you and like and provide you with caffeine? Okay, so that's the general framework.
Yeah. And the magic moment would be if programming is this weird discipline where sometimes the next 5 minutes, not always, but sometimes the next 5 minutes of what you're going to do is actually predictable from the stuff you've done recently. And so can you get to a world where that next 5 minutes either happens by you disengaging and it taking you through, or maybe a little bit more of just you seeing next step what it's going to do and you're like, okay, that's good. And you can just sort of tap through these big changes.
As we're talking about this, I should mention, like, one of the really cool and noticeable things about Cursor is that there's this whole diff interface situation going on. So like the model suggests with the red and the green of like, here's how we're going to modify the code. And in the chat window, you can apply and it shows you the diff and you can accept the diff. So maybe can you speak to whatever direction of that?
We'll probably have like 4 or 5 different kinds of diffs. So we have optimized the diff for the autocomplete, so that has a different diff interface than when you're reviewing larger blocks of code. And then we're trying to optimize another diff thing for when you're doing multiple different files. And sort of at a high level, the difference is for when you're doing autocomplete, it should be really, really fast to read. Actually, it should be really fast to read in all situations. But in autocomplete, it's sort of you're really like your eyes focused in one area. And you can't be in too many. The humans can't look in too many different places.
So you're talking about on the interface side, like
on the interface side. So it currently has this box on the side. So we have the current box, and if it tries to delete code in some place and tries to add other code, it tries to show you a box on the side.
You can maybe show it if we pull it up on cursor.com. This is what we're talking about.
So that box,
here.
It was like 3 or 4 different attempts at trying to make this thing work. Where first the attempt was like these blue crossed out lines. So before it was a box on the side. It used to show you the code to delete by showing you like Google Docs style. You would see like a line through it.
Oh, yeah.
Then you would see the new code. And that was super distracting. And then we tried many different, there was sort of deletions, there was trying to red highlight. Then the next iteration of it, which is sort of funny, you would hold on Mac the option button. So it would sort of highlight a region of code to show you that there might be something coming. So maybe in this example, like the input and the value would all get blue. and the blue was to highlight that the AI had a suggestion for you. So instead of directly showing you the thing, it would show you that it would just hint that the AI had a suggestion. And if you really wanted to see it, you would hold the option button, and then you would see the new suggestion. Then if you release the option button, you would then see your original code.
So that's, by the way, that's pretty nice, but you have to know to hold the option button.
Yeah.
By the way, I'm not a Mac user, but I got it. Option. It's a button, I guess. You people have.
It's it's just non-intuitive. I think that's the key thing.
And there's a chance this is also not the final version of it.
I am personally very excited for making a lot of improvements in this area. Like we often talk about it as the verification problem, where these diffs are great for small edits. For large edits, or like when it's multiple files or something, it's actually a little bit prohibitive to review these diffs. And so there are like a couple of different ideas here. Like one idea that we have is, okay, like parts of the diffs are important. They have a lot of information. And then parts of the diff are just very low entropy. They're like the same thing over and over again. And so maybe you can highlight the important pieces and then gray out the not so important pieces. Or maybe you can have a model that looks at the diff and sees, oh, there's a likely bug here. I will like mark this with a little red squiggly and say like, you should probably like review this part of the diff. And ideas in that vein, I think, are exciting.
Yeah, that's a really fascinating space of like UX design engineering.
Yeah.
So you're basically trying to guide the human programmer through all the things they need to read and nothing more.
Yeah.
Like optimally.
Yeah, and you want an intelligent model to do it. Like currently, diff algorithms they're just like normal algorithms. There's no intelligence.
Yeah.
There's like intelligence that went into designing the algorithm, but then there's no like, you don't care if it's about this thing or this thing, and so you want a model to do this.
So I think the general question is like, Matt, these models are going to get much smarter. As the models get much smarter, the changes they will be able to propose are much bigger. So as the changes gets bigger and bigger and bigger, the humans have to do more and more and more verification work. It gets more and more and more hard. Like it's just you need to help them out.
Yeah.
It's sort of I don't want to spend all my time reviewing code.
Can you say a little more across multiple files, Div?
Yeah, I mean, so GitHub tries to solve this, right? With code review. When you're doing code review, you're reviewing multiple diffs across multiple files. But like Arvid said earlier, I think you can do much better than code review. Code review kind of sucks. Like you spend a lot of time trying to grok this code that's often quite unfamiliar to you, and it often like doesn't even actually catch that many bugs. And I think you can significantly improve that review experience using language models. For example, using the kinds of tricks that Arvid had described of maybe pointing you towards the regions that actually matter. I think also if the code is produced by these language models and it's not produced by someone else, like the code review experience is designed for both the reviewer and the person that produced the code. In the case where the person that produced the code is a language model, you don't have to care that much about their experience. And you can design the entire thing around the reviewer such that the reviewer's job is as fun, as easy, as productive as possible. And I think that feels like the issue with just kind of naively trying to make these things look like code review. I think you can be a lot more creative and push the boundary on what's possible.
And just one idea there is, I think ordering matters. Generally, when you review a PR, you have this list of files and you're reviewing them from top to bottom. But actually, like you actually want to understand this part first because that came like logically first, and then you want to understand the next part. And you don't want to have to figure out that yourself. You want a model to guide you through the thing.
And is the step of creation going to be more and more natural language? Is the goal versus with actual writing?
I think sometimes. I don't think it's going to be the case that all of programming will be natural language. And the reason for that is, if I'm pair programming with Sualeh and Sualeh is at the computer and the keyboard, and sometimes if I'm like driving, I want to say to Sualeh, hey, like implement this function, and that works. And then sometimes it's just so annoying to explain to Sualeh what I want him to do. And so I actually take over the keyboard and I show him, I write like part of the example, and then it makes sense. And that's the easiest way to communicate. And so I think that's also the case for AI. Like sometimes the easiest way to communicate with the AI will be to show an example and then it goes and does the thing everywhere else. Or sometimes if you're making a website, for example, the easiest way to show to the AI what you want is not to tell it what to do, but drag things around or draw things. And like maybe eventually we will get to like brain machine interfaces or whatever, and it can like understand what you're thinking. And so I think natural language will have a place. I think it will definitely not be the way most people program most of the time.
I'm really feeling the AGI with this editor. It feels like there's a lot of machine learning going on underneath. Tell me about some of the ML stuff that makes it all work.
Where Cursor really works via this ensemble of custom models that we've trained alongside, the frontier models that are fantastic at the reasoning intense things. And so Cursor Tab, for example, is a great example of where you can specialize this model to be even better than even frontier models if you look at evals on the task we set it at. The other domain, which it's kind of surprising that it requires custom models, but it's kind of necessary and works quite well, is in apply. So I think these models are, like the frontier models are quite good at sketching out plans for code and generating like rough sketches of like the change, but actually creating diffs is quite hard. For frontier models, for when you're training models. Like you try to do this with Sonnet, with O1, any frontier model, and it really messes up stupid things like counting line numbers, especially in super, super large files. And so what we've done to alleviate this is we let the model kind of sketch out this rough code block that indicates what the change will be. And we train a model to then apply that change to the file.
And we should say that apply is the model looks at your code. It gives you a really damn good suggestion of what new things to do. And the seemingly for humans trivial step of combining the two, you're saying is not so trivial.
Contrary to popular perception, it is not a deterministic algorithm.
Yeah. I think like you see shallow copies of apply elsewhere, and it just breaks like most of the time because you think you can kind of try to do some deterministic matching and then it fails, at least 40% of the time. And that just results in a terrible product experience. I think in general, this regime of you are going to get smarter and smarter models. And like, so one other thing that apply lets you do is it lets you use fewer tokens with the most intelligent models. This is both expensive in terms of latency for generating all these tokens and cost. So you can give this very, very rough sketch and then have your small models go and implement it because it's a much easier task to implement this very, very sketched out code. And I think that this regime will continue where you can use smarter and smarter models to do the planning, and then maybe the implementation details can be handled by the less intelligent ones. Perhaps you'll have, maybe O1, maybe it'll be even more capable models given an even higher level plan that is kind of recursively applied by Sonnet and then the apply model.
Maybe we should talk about how to make it fast.
Yeah.
I feel like fast is always an interesting detail.
Fast is good.
Yeah. How do you make it fast?
Yeah. So one big component of making it fast is speculative edits. So speculative edits are a variant of speculative decoding, and maybe it'd be helpful to briefly describe speculative decoding. With speculative decoding, what you do is you can kind of take advantage of the fact that, most of the time, and I'll add the caveat that it would be when you're memory bound in language model generation. If you process multiple tokens at once, it is faster than generating one token at a time. So this is like the same reason why if you look at tokens per second with prompt tokens versus generated tokens, it's much, much faster for prompt tokens. So what we do is instead of using what speculative decoding normally does, which is using a really small model to predict these draft tokens that your larger model will then go in and verify. With code edits, we have a very strong prior of what the existing code will look like. and that prior is literally the same exact code. So what you can do is you can just feed chunks of the original code back into the model, and then the model will just pretty much agree most of the time that, okay, I'm just going to spit this code back out. And so you can process all of those lines in parallel. And you just do this with sufficiently many chunks, and then eventually you'll reach a point of disagreement where the model will now predict text that is different from the ground truth original code. It'll generate those tokens, and then we kind of will decide after enough tokens match the original code to restart speculating in chunks of code. What this actually ends up looking like is just a much faster version of normal editing code. So it's just like, it looks like a much faster version of the model rewriting all the code. So just we can use the same exact interface that we use for diffs, but it will just stream down a lot faster.
And then the advantage is that while it's streaming, you can just also start reviewing the code
exactly
before it's done. So there's no big loading screen. So maybe that is part of the advantage.
So the human can start reading before the thing is done.
I think the interesting riff here is something like, I feel like speculation is a fairly common idea nowadays. It's like not only in language models. I mean, there's obviously speculation in CPUs, and there's like speculation for databases, and there's like speculation all over the place.